All right, so we're looking at number 20 in our practice test. So it's in 2017, a pollution index was calculated for a sample of cities in the eastern United States or eastern states using data on air and water pollution. Assume the distribution of pollution indices is unimodal and symmetric, so that's important. The mean of distribution was 42.2 points. We're going to put this down here. We're going to need this in a minute. That's our X bar is 42.2 points with a standard deviation S is equal to 11.4 points. Complete parts A through C below. So they're asking what percentage of eastern cities would you expect to have a pollution index between 19.4 and 65? What percentage of eastern cities would you expect to have a pollution index between 30.8 and 53.6? And then the pollution index for an eastern city in 2017 was 50.5. Based on it, was this unusually high? Explain. So I start seeing stuff like this and I'm like, hey, that numbers, those look like they might be near the 42. And if I maybe add and subtract some of my deviation, right? So the first thing that went in my head, empirical rule. So that's what we're going to use. I wrote it up here to help you remember. First thing, empirical rule can only be used when something is unimodal and symmetric. Basically, you need a bell curve like what I drew in purple below. So this lovely thing down here, okay? Basic shape, you know, in the center, we have our lovely mean right here. Should be at the peak, basically. So X bar is in the center. And then we will be applying the empirical rule to determine where 68% of the data falls. So 68% of the data, these things are in color coded kind of to help you. So 68% of the data, so 68% of the data is within one standard deviation. So that means if I add the standard deviation and I subtract it from the mean, then that tells me the boundaries within which, and what color was that? With the dark purple, let's go with that, 68%. So this is my, oops, come back to this one, undo that. Okay, so if I go here and here, so if I take 42.2 and I subtract 11.4, if I take 42.2 and I add 11.4, so we'll do that in a minute, then that's going to give me the area under this curve is 68% of my data. So that's 68%. And according to the empirical formula, empirical rule. So next we have 95% is within two standard deviations. So that's going to be way out here. So for that one, you would do 42.2 minus 2 times 11.4. And then for this, you would do 42.2 plus 2 times 11.4. Okay. And then my last category or my last value that we do, 3 standard deviations. So virtually all, it's like 99.7, something like that percent. I don't remember off the top of my head right now, but oh, I didn't do this. So this would be 95 or within these yellow. So that's a lot already. So 95% there. So then the red is virtually all of my data is going to fall with from this all the way across here. So basically, I mean, that's almost the whole thing anyways, right? Okay. So we just need to calculate and see where these numbers lie and where that falls on here. So let's go ahead. I'm going to do 42.2 and I'm going to subtract 14.4. And I'm double checking my numbers because I did this earlier and I was doing weird things. 42.2 minus 11.4 is going to give me, again, that calculator did not do what I wanted. 42.2 minus 11.4. I think I hit 0 instead of point. So that's 30.8. So I'm going to erase this and I'm going to replace it with my 30.8. Okay, these are the one significant, or not one, one standard deviation away, and then 42.2 plus 11.4 is going to be 53.6. So I'm going to take this out, and that would be, oh goodness, that's the wrong one, 53.6. So those numbers starting to look familiar, right? The next one we want to do is we're going to do where we're subtracting 2 times that, or you could just take this number and subtract another 11.4, however you want to do it, same thing. So I erased it. So I'm just going to do 42.2. My computer's dying. Let me plug that in real quick. That would be bad. I don't really need it, but I'm using it to pause the recording. So, okay. There we go. So if I take 42.2 minus twice 11.4, I will get 19.4. Good. Checking it. I took a shortcut in my head. I want to make sure that was right. So this one should be 19. Oh, goodness. My iPad moved 19.4. And then on the other side, again, we are going to erase all of this. And now we are going to do the other thing, 42.2 plus 2 times 11.4. And that is going to give me 65.0. Okay, so let's look up here for the first one. I'm going to erase some of these colors because these colors kind of match the ones I was using, right? So for the first one, where it's asking me about 19.4, right, and 65, I expect it to be, since those are two, right? So this is 2 standard deviations from my mean. I expect it to have 95% of my data. For the next one, I know 30, oops, I keep using that one. I'm going to stop that. It's kind of thick for today. 30.8 and 65.6, 63.5, I don't know what it is. Those, I said that wrong again. 30.8 and 53.6. In between there, we have 68% of our data. Okay, so that just comes from this being 1 standard deviation from the mean, both of these values. So if you take your X bar, you subtract your S, your standard deviation, you'll get those 2 values. Now for the last one, we're gonna have to try and read it because I wrote on it, but I like the pretty graph. The pollution or distribution function. The pollution index for an Eastern city in 2017 was 50.5 points. Based on this distribution, was this unusually high? And explain. So where would this be on my distribution? I'm looking at 50.5. So 50.5 is here, right? Was it 50.5? Yeah, it's somewhere in here, right? It's gonna be somewhere between those two. Yeah, so as long as it falls within 2 standard deviations, we're not going to say it's unusually high. So we're going to say, no, it's not unusually high, right? Because it falls within. It's not exactly, because exactly 2 standard deviations would be 65 or 19.4, but it falls within 2 standard deviations, and therefore it's not an unusually high value of the pollution index, okay? So 50.5 falls within. So again, this was question 20 on our practice test for 1, and its question ID is 3.2.31. So this was from our chapter 3 work. And we were reviewing the empirical rule.